And following the pattern of terrible numbering, we have 3f. Find all solutions on negative infinity to infinity, so aka all real numbers, for negative 2 cosine squared theta plus 3 sine theta plus 3 equals 0. Well, notice we have a cosine squared theta and a sine theta, which is a problem. So we're going to need to use a Pythagorean identity to turn cosine squared into sine squared. So think about what we know. We know that sine squared theta plus cosine squared theta equals 1. So let's subtract sine squared theta from both sides to get cosine squared theta equals 1 minus sine squared theta. Because now we can make this substitution right there. So we have negative 2 parentheses 1 minus sine squared theta plus 3 sine theta plus 3 equals 0. Let's distribute. Negative 2 times 1 is negative 2. Negative 2 times negative sine squared theta is positive 2 sine squared theta. And we still have plus 3 sine theta plus 3 equals 0. So we have 2 sine squared theta plus 3 sine theta plus 1 equals 0. And again, I'm going to make a substitution. I'm going to let x equal sine of theta, because then I can say 2x plus 2x squared plus 3x plus 1 equals 0. Well, how does that factor? We need to have, let's see, doobity-doop. Need a 2x and an x right there. Need to multiply to 1, so my only options are 1 and 1. And I need to add to 3x, so I have to be plus and plus right there. That equals 0. So then x has to equal negative 1/2, and also it has to equal negative 1. But remember, x is really sine of theta, so we have sine of theta equals negative 1/2, and sine of theta equals negative 1. So draw a unit circle. Again, where is sine equal to negative 1/2? Well, that's going to happen right there and right there, which is, what is that? 7 pi over 6 and 11 pi over 6. And then when is sine of theta equal to negative 1? Well, that's happening straight down there at 3 pi over 2. So those are our 3 theta values. Theta equals 7 pi over 6, 3 pi over 2, and 11 pi over 6. But we want the solutions on the interval negative infinity to infinity. So all we need to do is state those theta values, but then add to them full revolutions of the unit circle. Because if I go all the way around, I get back to the same spot. So all I need to do is say that theta equals 7 pi over 6 plus 2 pi n, and also 3 pi over 2 plus 2 pi n, and finally 11 pi over 6 plus 2 pi n, and these are all for all n in the set of integers. That's just saying n is any whole number, positive or negative, any integer, and multiplying by the 2 pi is going to make us go around a full revolution, and that's all it is.